Hello everyone, this is Engineer Irfan Ali with my team member Engineer Mohammed Shoaib for the project Non-Essential Load Management from Service Provider under the supervision of Dr. Fahim Akhtar Chachar and co-supervision of Engineer Veerbhan. This is the outline of our today's presentation, which include introduction, methodology, problem statement, motivation, aims and objectives, literature review, results, recommendations, and references. Introduction. Task 1. An automatic scheme for service provider to manage non-essential loads. Electrical power is the basic demand for the development of a state. The commercial and domestic structures require uninterrupted power supply from the service provider. To fulfill the demand of consumers, the service providers focus to provide electrical power to the essential loads only by introducing, controlling, and monitoring systems into the power system. Traditional monitoring system require the installation of sensors to every load of interest. As an element of smart grid, using modern technologies, we have designed a scheme for facilitating the service providers to monitor and control the non-essential loads in user side. This is the general power system in which electricity is generated far away from the residential areas. Electricity is generated and it is transmitted through towers to the substation. Substation electrical power is managed and distributed to the loads such as domestic load, commercial load, agricultural loads, and industrial loads. Now, actually, what happens when the load is shedded from the substation? All the loads connected in any feeder, such as domestic loads, are cut from the power. Means the power of that feeder is interrupted. Now what we want, when the power is interrupted of that feeder, only the non-essential load must be interrupted and the essential load should get power continuously. Introduction of task 2. Wireless switching of AC outdoor unit. The wireless system installation in electrical power sector will reduce net expenses and human efforts by switching wirelessly on required time. Due to increment in temperature, air conditioners have grabbed the attention of individuals and organizations for luxurious and easy environment. In Pakistan, 18% of urban areas and 1.7% from rural areas possess air conditioners. The air conditioners market is projected to grow at compound annual growth rate of 7.2% during 2017 to 2023. Thus, by utilizing air conditioners in proper and effective way, we can save up to 18% of the energy. In this project, we have designed a device which allows user to switch outdoor unit of AC wirelessly without being present at the station. This is the circuitry which shows the working of device, in which a mobile app, an ESP32 relay, magnetic contactor, AC outdoor unit, and AC indoor unit are there in the circuit. How it works? A mobile app, a command is given through the mobile app to the ESP32 through Wi-Fi. ESP32 initiates a command to switch the relay, and the relay turns on or off the magnetic contactor. Magnetic contactor then switches the AC outdoor unit. Just like this, when the user gives command through mobile app, the ESP32 turns off the relay. You can see here from this LED that this is not turning on now. Then the relay initiates a command to the magnetic contactor, and magnetic contactor opens the circuit, and current does not flow to the AC outdoor unit. Motivation. The utilization of electrical energy in uncontrolled environment causes wastage of energy. In result, consumer faces overbilling and theft of electricity. Government announced shopping malls, markets, wedding halls, and restaurants to close down early to save electricity. Thus, need to design a scheme for service provider that allows them to manage and control non-essential load of consumers remotely. Problem statement. With increasing consumption of electric energy, the management of power consumption becomes more and more important. There is a great need to manage the non-essential loads during the peak hours. Due to switching of essential loads, we encounter with loss of production and productivity, medical life support, health safety. 150 deaths in 2013 occurred due to switching of essential loads. Security breaches and loss of control also are faced due to switching of essential loads. Moreover, electricity theft is also a big issue. Figure in right side, we can see a main meter through which there are two submeters, submeter 1 and submeter 2. With submeter 1, the three loads are connected, in which in air conditioner, air cooler, and deep freezer. Now, what we want, when there is a unbalancing between generation and the demand, service provider must be able to interrupt the power of any of the load. For example, service provider is interested in interrupting the power of air conditioner. Aims and objectives: to design a device for switching outdoor unit of AC wirelessly, to design wireless controlling and monitoring system of non-essential load management based on modern technologies, including Wi-Fi, radio frequency, and ESP-NOW. We provide a scheme with the help of smart grid that can shut down non-essential load to avoid deaths in business and other type of losses. Moreover, to implement wireless controlling and monitoring system depending on low cost and must be reliable. At last, comparative analysis and identification of the system weakness of existing wireless monitoring system is also aim of this project. Literature review. A paper presented by Pakistani author in which author proposed a design of smart energy meter with overload trip facilities, which was based on GSM and included a microcontroller. Moreover, authors briefly describe types of smart energy meters in this paper. In Pakistan, the electrical losses are increased to 90 billion rupees due to inappropriate manage and control of electric power. Smart energy meters are able to send automatic notification about real-time consumption of electricity to the consumer. This helps consumers as well as service provider to monitor the theft of electricity. A prototype of smart meter module based on GSM technology was developed by experts for the energy monitoring and control. This prototype module required energy consumption pattern from the consumer premises and send it to ESP using short message service and GPRS technology. Another paper was prepared by a seminar by Arun is have title of seminar report on ZigBee, in which characteristics of ZigBee were presented. Characteristics of ZigBee are that ZigBee requires low power, it has low data rate, and secure wireless protocol. It supports star, ring, and mesh topologies. A survey of different wireless technologies is also conducted. That ZigBee creates a personal area network. It is used for home automation and medical device data collection. GSM has improved data transmission, and Bluetooth avoid interference, and it could be upgraded easily. Another paper in which the design and development of GSM Bluetooth-based load management system is introduced. The circuitry consisted of 8 MHz microcontroller, relay drivers, and power supply unit. In domestic and commercial sectors, there are numerous types of loads. To control all the electrical loads, manpower is required. Manpower is directly related to maintenance cost. Thus, to control load wirelessly, radio frequency communication system is the best choice due to easy installation. It uses input circuitry, encoder, transmitter, receiver, and decoder. Methodology of the project. The figure showing a web app, microcontroller, and communication unit. User gives command through web app to the microcontroller, and microcontroller sends the command through communication medium to the relays. Now relay operator control the magnetic contactor. And the current transformer and the potential transformers are connected to measure the current and the voltage respectively of the loads. The loads are domestic loads, commercial loads, industrial and agricultural loads. In this flowchart, the system compares the generation with the user demand. If the generation is greater than the user demand, the system operates normally. If the generation is less than the user demand, the system will manage the non-essential load priority-wise. In this project, we have given a priority to the commercial loads and then the domestic loads, meaning that when there is unbalancing, the system will manage the loads of a commercial feeder, then it would go to the domestic feeder in case of unbalancing. So, in this, if the generation is less than user demand, then the system will manage the loads of medium priority feeder. Similarly, if the generation is not balanced, then it would go to the low priority, which is agricultural load. And the last, we would go to the industrial load, which is rare, very rare case, because industrial loads require uninterrupted power supply. The results and discussions. This is showing that the mobile app, ESP32 transmitter and receiver means radio frequency module with encoder and decoder. And there are 4 loads are connected, which are named domestic load, commercial load, industrial, and agricultural load. Now, when the service provider turns on any load, for example, domestic load, you can see that the domestic load is now on, then commercial load, then agriculture, and then industrial load. Now, when there is any case of unbalancing, like that, there is overloading, the system will automatically turn off the domestic load to balance the system, just like this. The future recommendations are that this scheme and device could be controlled with GSM technology to extend the scheme for other non-essential loads as well. And then there are references.